So hello guys, welcome back to my channel with another exciting video. So today I am gonna explain the new security project which is made using Arduino UNO, NodeMCU and various components. I named it LockMate, which is a smart lock which opens and closes the servo motor based door through online and offline mode with an advanced password security for offline use and email biometric authentication for online security. This project demonstrates the real-world application of IoT or a small-scale cyber-physical system. The main objective of our project is to design a smart lock which authenticates user and locks and unlock the door. Authenticated user can monitor and access remotely. And each and every notification is sent to owner's email and Blynk IoT app. Let's see the components required for our project. You can pause and note. The main component is Arduino UNO, NodeMCU, keypad, SG90 servo motor, power supply. And to write the code we need Arduino UNO IDE. If you don't know how to set up Arduino, please watch the first video of this playlist, link in the description. And you also need Blynk IoT app installed in the host device and internet connection. Also download libraries like ESP8266 Wi-Fi.h. Servo.h and Keypad.h, etc. Now let's see how our system is designed and our system workflow. Firstly, during offline mode, we give input to our system through the keypad, which is predefined in the code of Arduino. मतलब पहले ही set कर दिए सो password को keypad से enter करना. Then the Arduino process the password, and if matched with stored password, then servo motor opens the door. Lekin if the entered password is incorrect, the door remains closed and buzzer makes sound. Let's see how circuit is connected and how each component works. Don't worry about hardware connection. In the description I had given drive link, which contains code, along with pins connected to each components. This is a servo motor, which receives commands from the Arduino and it controls the door. This is a buzzer, which receives commands from the Arduino, and it makes sound on incorrect password. Do not worry of this circuit. It's very simple. It's called as voltage divider circuit. The image to connect it is in drive, and the link is in the description. It's used when our Arduino transmitter pin is connected to receiver of NodeMCU. As the Arduino sends 5-volt signal, and NodeMCU need 3-volt signal for high. So this circuit protects our NodeMCU from high voltages. This is a keypad of 4 rows and 4 columns. This is used to input password from the user during offline use. This is a LED, which indicates status of the system like door open then green light or incorrect password red light. This is a breadboard and connects all the components. This is called as NodeMCU, that is the heart for wireless communication. It manages the communication between our IoT device and the user application. Code link is in the description. This is an Arduino, which controls everything. The code will be explained next. So now I will explain the pin connections and the code. Open the drive given in the description and access its code. This Arduino code contains libraries we included at the top. Then we define to which pin slots of Arduino we are connecting, the command pin of servo motor, the LED pins and the rows and columns of keypad, and the TX and RX pins for NodeMCU, and the logic to control input password and the communication with the NodeMCU Wi-Fi, which connects to Blynk IoT app. Observe the cursor highlighted code so you may get idea of code. Don't worry. In the next video I will tell you how to get this template ID and token ID from Blynk IoT App. And also in the next video I will tell you how to set up Blynk IoT App. Comment if you need it. This is how our system will look like after connections. I did not use PCB, so this looks complex, but if you follow the connections based on code, then no issues, it's very easy for you. This is the schematic diagram. Please watch upcoming videos for setting up Blynk IoT app and which makes our project complete. Thanks for watching.